Today we're looking at the chain rule, and it's used for differentiating more complex functions. And I'll have some specific examples of that as we go along today. And we use it to differentiate what's called composite functions. In composite functions, they're, as I said, a bit more complex than simple ones. You know, a simple function might be something like y equals x cubed, even y equals 3x to the power of 5, simple ones like that. Once we get into squaring, instead of squaring x, say squaring something like x plus 5 and differentiating that, or 2x plus 3 to the power of 5, when we get to differentiating expressions like that, they're a bit more complex, and we have to do either the chain rule or another rule that I'll show you a little bit later on. There are simpler ways of finding derivatives other than using the chain rule. Right? I'm going to show you the chain rule, and I don't think you'll end up using it very much. But the thing about it, it does work, and it's always a good backup. So please practice it. Don't discard it completely. Use it in finding some of these answers, even though it becomes obvious that there's a bit of a quicker way as we move on. That is the chain rule there. dy dx equals dy du times du dx. Now what is u? That's the good question there, and I'll demonstrate what u is by doing an example on the next slide. Okay, so we'll need that rule as we go along. dy dx equals dy du times du dx. Alright, here we go. I've got to find dy dx, and my y is 3x minus 2 to the power of 3. So what's u all about? Well, that's what I do first up here. I let my expression here, that's raised to the power of 3, I'm letting u equal 3x minus 2. Okay? Now, y would therefore equal u to the power of 3. Now at this stage I'm going to paste in the chain rule. Okay, over here to the side. And you'll see that the chain rule says dy dx equals dy du times du dx. So let's keep that firmly in our sight here as we proceed. So what's dy du? What is that one there? Okay, well, it's the derivative of this expression. We've got y equals u cubed. So dy du is going to be 3u squared. Okay, alright, well what's du dx? Okay, well we know that u is, let's put an arrow down here, 3x minus 2. So du dx is going to be the derivative of u, which is just 3. So you can see now how this is starting to develop. Now I'm going to apply the chain rule in the purple box there. So dy dx equals dy du, which is 3u squared, multiplied by du dx, which is 3. So we get 9u squared. So let's just take this part here, and I'll put it on the next slide. So you see where we're up to. Oops. Let's put it over here. Okay, now we know that u, because we substituted early on, we know that u equals 3x minus 2. Okay, so if we substitute that back in now, we get 9 outside of 3x minus 2 squared. And there's our answer to that question. It's 9, 3x minus 2 squared. Let's just review. It's a complex function because we've got the function 3x minus 2 raised to a power of 3. The chain rule means that you've got to do a substitution, and what you usually do is substitute for that bracket there, which is 3x minus 2. So it now becomes u cubed. Chain rule, there it is in the purple box. You've got to find dy du, and you've got to find du dx. Dy du is the derivative of y equals u cubed, which is 3u squared. du dx is the derivative of that bracket, the one you substituted. That's 3. The rule says then that you times them together. Then, once we've done that, we get 9u squared and we substitute back in. Let's look at another example. Here's my second problem using the chain rule. It's x squared minus 2x in brackets cubed. As we did last time, and this time we're using f of x and f dash of x, but I usually like to use y here, as long as when we do the answer, we use f dash x as our notation. So let's go back here and remember the chain rule. Just get rid of those ticks. We'll copy that over so we know what we're using. Put that over to here. Okay, there's our chain rule. Now, our substitution is u equals x squared minus 2x. So we've done our substitution there. We've let u, in fact I should have put the word let there, so squeeze that in. Let u equal x squared minus 2x. Therefore, y equals u cubed. Therefore, dy du equals 3u squared. We also, so we've got dy du, we also need du dx. Okay, there's our u. So du dx is going to be the derivative of the bracket, which is 2x minus 2. So we've got dy du and du dx. So we'll copy those over to the next slide. Now to find dy dx, what we do now is multiply them together according to the chain rule. Dy dx equals dy du, which is 3u squared, multiplied by 2x minus 2. Now we know that u is the bracket x squared minus 2x. Okay, so it's going to be 3 times x squared minus 2x all squared, so I've put u back in now, multiplied by 2x minus 2. Okay, we're going to put the 2x minus 2 out the front, so we get 3 outside of 2x minus 2, outside of x squared minus 2x squared, like so. Now we can actually take out a 2 outside of that bracket. Remember that 2x minus 2 equals 2 outside of x minus 1. So if I do that, the 2, so imagine now that I'm factorising that into that, that becomes 3 times 2 is 6, outside of x minus 1, outside of x squared minus 2x, all squared. So same deal. I made an initial substitution. I let u equal x squared minus 2. I then substituted for u, so y equals u cubed. Then we get dy du and du dx. Okay, dy du is the derivative of the y expression here. Du dx is the derivative of that u expression. You then, once you've got those two things there and there, you multiply them together. I then substituted back for u again, so 3u squared becomes 3 times that bracket squared, and then some tidying up at the end, and I arrive at the answer. And as I pointed out before, I must make sure I put f dash x equals the answer there, because we're using f of x, not y terminology. Alright, there's a couple of examples of using the chain rule. Now I'm going to go back to that first example, and instead of using the chain rule, I'm going to use a different rule. Okay, so here we go. With the shortcut here, what we can do, first of all, dy dx here, what we're going to do is put the index like we have in the other shorter rules, we're going to place it out the front. So we get 3. Then we multiply it by the derivative of the bracket. Now the derivative of the bracket is 3. Then we multiply by the bracket as it stands, reduced by a power. So index comes out the front, multiplied by the derivative of the bracket. So there we go, multiplied by the derivative of the bracket, and then multiplied by the bracket reduced in power by 1. Answer 9 outside of 3x minus 2 squared. Now you see straight away that's what we got before using the chain rule, but what I just did was much quicker. Okay, I didn't have to muck around with you and that sort of thing. So by all means use that, but bearing in mind you can use the chain rule as well. Okay, that second example that we did, let's use my shorter cut now to find the answer here. So, oops. F dash x equals, bring the index out the front, 3, multiplied by the derivative of the bracket, 2, which is 2x minus 2, multiplied by the bracket, reduced in power by 1, back from 3 back to 2. Now we still have to do what I did before, and that is factorise that bracket there. So we're going to get 3 times 2 outside of x minus 1, x squared minus 2x all squared, equals 6 outside of x minus 1 outside of x squared minus 2x all squared. Compare that now with the answer that we got. You see it's exactly the same down here as what I got just then. So index out the front, multiplied by the derivative of the bracket, reduce the bracket by 1, a power of 1. Let's look at this one now. See. Now first thing we have to do here is change this to index form. So it's 5x plus 2 to the power of a half. And I won't use the chain rule this time. I'm going to use the shorter rule that I just showed you. So dy dx equals a half multiplied by the derivative of the bracket, which is 5, multiplied by the bracket, reduced by 1. So it now becomes negative a half. So what we've got now is a half times 5 is 5 on 2, multiplied by 5x plus 2 to the power of negative a half. Mentioned before that we shouldn't make all negative indices positive. So what I'm going to do now, the 5 is on top, so is the 5x plus 2 to the negative a half. It's in on the numerator there. So what I'm going to do now is to take it to the bottom, so onto the denominator, and then it changes from negative a half to positive a half. Now, as we know from our work on indices, to the power of a half is the same as the square root. So it becomes 2 square root 5x plus 2. And there's our answer. 5 over 2 square root of 5x plus 2. Next question, we've got g of x equals 2x cubed plus x to the power of negative 2. Find g dash x. So find the derivative here. So g dash x equals, so the negative 2 comes out the front. We multiply it by the derivative of the bracket, which is 3x squared plus 1. Sorry, 6x squared plus 1. Multiplied by the bracket, reduced in power by 1. So it goes from negative 2 back to negative 3. Last step, negative 2 outside of x squared, 6x squared plus 1 over, and to make that negative index positive, we can make it 2x cubed plus x to the power of 3. Last example for this video, example 5. If f of x equals the square root of x squared minus 2x plus 1, find f dash 3. So another extra step here. But before we find f dash 3, we have to find f dash x equals question mark. So before we do that even, we're going to change this into index form, as we must before we can go any further. So instead of the square root of that expression, it's that expression to the power of a half. Equals, a half goes out the front, gets multiplied by the derivative of the bracket, and then the bracket itself gets reduced in power by 1 back to negative a half. Tidy that up. Okay, we get 2x, or 1 times 2x minus 2 on the top. On the bottom, okay, notice how I've just dropped the 1 there because it's 1 times that. And on the bottom, the 2's there in the denominator, and we get this expression here to the power of positive a half, because when we take something from numerator to denominator, the sign changes. On to the next slide now. We can make this, we can do square root form. Now what we have to do is find f dash 3, and to do that we substitute in the value of 3. So I'm putting in here 3 for x, so 3 squared minus 2 times 3 plus 1 equals, on the top we've got 6 minus 2 is 4, 2 times the square root of 9 plus 1 is 10, minus 6 is 4. The square root of 4 is 2, so on the bottom we've got 2 times 2, which is 4, so we end up there with a value of 1. So that is our answer. Right, now time to have a go at exercise 7D. Try page 334. Try and do some problems with the chain rule. In fact, questions 1 and 3 force you into that situation. But use your judgment as well. If you think you can use the other rule, which is quite important to do, please do so as well. Okay, that's about it for now. So have a go there at 7D and see how you go with the chain rule and finding the derivative of composite functions. Bye for now.